You know they call this the Tesla of washer and dryers?
Yeah, I did hear that.
So you know we had to try this thing out. This is the GE Profile heat pump washer dryer combo. And I'm gonna tell you why this thing is genius. We've had it for 6 months, bought it with our own money, not sponsored. And we've had plenty of time with it to see how it works, pros, cons. I wanna walk you through the genius of this product. It actually solves 4 problems that we had all in this one tiny little thing. So this episode, let's figure out if this would be right for you. I'm Ricky, and Stupid Da Vinci.
Tiny little thing.
This video is sponsored by Fume.
All right, to start with why this thing is genius requires looking at this. This is the only plug this thing has. If you had a normal washer and dryer, you'd have a 110 plug for the washer and the dryer, right? So you'd have 2 of these. And then for the dryer, you would either need natural gas hookup or a 240 volt, right? Instead of one of these, because it uses a lot of electricity. The average electric dryer pulls 4,000 watts from the wall. This is a 110 plug. At full throttle, I'm guessing it'll use around 1,000 watts. We have ourselves a little test setup, so we'll figure all this out. But this is what makes this so genius. If you live in a house where you don't have a natural gas hookup and electricity bills are really high, this could work for you. Or if you have neither 240 or 110 or gas, all you would need is a plug like this, and you could run one of these. It doesn't even have a vent, which gets into the first reason why this thing is genius. We had a vent back here, and we thought it worked. In fact, our old owners of the house that we bought this from told us that their dryer burned out. And when we got our new washer and dryer in, the dryer started giving us warnings of excessive back pressure. So we got under the house, and it turns out that vent runs 100 feet under the house and vents on the other side. The problem is there's such a long run of pipe that the back pressure was too great and it would burn out that motor. So we couldn't use that. So for the first year before we bought this, we'd run a duct out this door and we just ran it around and vented it outside. That's what we had to do. That takes care of that because this has no vent. There's nothing to vent. There's no natural gas fumes, and all the humidity and moisture even doesn't need venting. And we'll tell you why that is. The second problem that we had is in this house, we didn't have a utility sink. And that's because we had a washer and dryer like normal, and there was no room for one. But we do a lot of painting or projects, and we don't want to get our kitchen or bathroom sinks dirty, so every house, I think, should have a utility sink. And now that we have this all-in-one combo unit, we actually had room to put in a utility sink.
I can't believe it's already 2024, and that means it's New Year's resolution season. And while cold turkey may be great on sandwiches, there's a better way to break your bad habits. And where our sponsor this week, Fume, comes in. Fume is an innovative, award-winning flavored air device that does just that. Instead of electronics, Fume is completely natural. Instead of vapor, Fume uses flavored air. And instead of harmful chemicals, Fume uses all-natural, delicious flavors. Instead of bad, Fume is good. It's a habit you're free to enjoy and makes replacing your bad habit easy. Maybe you like the idea of a built-in break, a chance to center your mind or get some fresh air, so keep doing that guilt-free with Fume. Stopping is something we all put off because it's hard, but switching to Fume is easy, enjoyable, and even fun. Fume has served over 150,000 customers and has thousands of success stories, and there's no reason that you can't be one of them. It's a beautiful combination of wood and steel, and it's fidgety and fun. Join Fume in accelerating humanity's breakup with destructive habits by picking up the Journey Pack today. Head over to tryfume.com/TubaDaVinci or scan the QR code and use code TubaDaVinci to get 10% off when you get the Journey Pack today. That's tryfum.com/TubaDaVinci. Huge thanks to Fume and you for supporting the show.
Remy,
Yes.
what do you think about this thing? You a fan?
Massive.
Massive?
Yeah.
I just called it tiny. Massive. Okay, it's massive. So Remy,
Yes.
the third problem is we want to make this house entirely net zero. And this old machine that we had was natural gas, which we don't want to do. We wanted to be pure electric. But the problem is I don't have a 240 volt plug back there. So an electrician quoted me about $800 to run a new 240 line up and over back there before I could even buy the machine. And then the next problem is if I did that, if the power went out or we were totally off grid, that dryer would pull 4,000 watts from the wall. Now our entire battery backup system can power about 15 kilowatts. That would eat a healthy part of it, almost a third. And if the air conditioner turned on or something else kicked on too, we'd be pushing it, and I didn't want to do that. This pulls around 1,000. Let's actually figure out how much. Remy, you know what this is?
What?
This is called a kilowatt. It'll tell us how much power this thing uses, all right? So we're gonna plug it in.
I think I heard the name. I think I heard the name, but not the thing.
Yeah, well, you're thinking of the kilowatt, the unit of measure. But this is a funny play on words called a kilowatt. You see? Look. See how they spelled it out? But yes, it'll tell us how much power we're using, right? "30 minutes later." Okay, we got ourselves a bit of tape. Now we can see how much that uses. We'll switch this over to wattage, okay? It's off right now, obviously, so we'll fire it up now. All right, it's telling us the detergent is low, so let's fill that up before we start. So because we're using the laundry sheet and not the typical liquid, let's go ahead and turn off the smart detergent. We'll turn that off. The app told me to do that, so cool, that should be good. Yeah, the app is really cool. It tells us it's off right now. Let's go ahead and hit run. So it looks like just running that drum, the electric motor to run the drum pulls around 60 watts or so. The washing load cycle is actually really low energy. It should be pretty low. Let's see the kilowatts. Okay, this is the kilowatt hours. So far, we've not even used 0.01 yet. We'll wait on that, and we're at 60 watts. So I almost forgot something really, really important. Top tip, always clean your lint filter on the dryer. But because this is an all-in-one, you gotta do it before the wash cycle too, right? I mean, I'm gonna do it right now. So a electric resistive dryer or a gas dryer both produce heat, right? They convert either electricity or gas into heat. So as a result, inside of this drum, we have a hot zone, right? And that hot, extra high temperature air will increase the level of evaporation from the clothing and dry it out. Now you have huge levels of humid, wet air that you have to duct out. Otherwise, there's no extra room for any extra evaporation, right? Once the level of humidity in the air is 100%, it can't take on any more water and your clothes won't dry. So that air has to be vented to the outside, right? This, though, causes a problem. If you have a dryer inside your house, like if you have a laundry room inside your house, you guys saw that was our garage, so that's not a problem for us. But if you do, what this is doing is taking the air in your house and dumping it outside. What that means is overall in your house, you'll have a low pressure zone compared to outside. And let's say it's winter right now, we're in December, that will pull cold air through all the leakage spots in your house around windows, seals, and it'll pull, like if you have the heater running inside your room, that heat is getting ducted outside and colder air will get sucked into your house. And that happens if you have an indoor dryer currently. With the heat pump system, that's not a problem. And the reason why is with a heat pump, yes, you have a hot zone in here, right? Inside the washing drum, the dryer drum. But heat pumps don't produce heat. They just move it around. They do make a little bit of heat, right? There's a compressor and the evaporator, and those machines do produce a little bit of heat, but not much. So as a result, you have to have this heat go somewhere, right? Well, the heat goes into the cold zone up here. So heat is moved from here down to here. As a result, just like on our gas dryer, we have a high temperature area. That high temperature will increase the level of evaporation, and you've got humid air. You got to dump it, but there's no vent. How does it work? Well, that air then is circulated to cold coils. If you ever touch like the cold coils of an air conditioner, that is what's happening up here. And that cold coil will cause the water vapor to condense and get collected. And that collected water goes out the same pipe that we have running into our not Home Depot bucket. And all of that happens without any air transfer. This means that you don't have a low pressure area inside your house, which means that if you have the heater running or the air conditioner in the summertime, that air stays with you. And you don't have extra air getting pulled in through all your little leakage spots in your house. And when we get out there, we'll run the FLIR imaging camera and see how that all works and stuff. I'm really curious. I haven't done it yet. First time for me as well. But that is a huge benefit of the heat pump dryer. All right, so the wash is now complete and we're in dry mode. One of the things that this thing will do is take extra time in that spin cycle to really get all the water out mechanically as much as it can. That way it can dump all that water out before starting the dryer. Now we are at 0.64 kilowatt hours now, and we still have an hour and 11 minutes left on the dry cycle. We'll see how we all end up. But at this point, we would end up, we're pulling 955 watts from the wall or so, like we mentioned, about 1 kilowatt or less. But we'll see how we end up. My prediction is probably around 1.7 kilowatt hours for the entire load. And we'll see how much that translates to in terms of savings and stuff. But the fact that this can run that air through, condense the water out in one closed loop is why they can accomplish this without a vent. And like I mentioned, that's pretty genius. Now, we have an infrared camera running. We'll show the footage. But as you see that, you'll notice it's very hot inside the drum. That's where the heat pump is pumping out the heat. That will cause evaporation, and then you'll notice there's probably a cold section right around here, obviously, because the filter's here, so the air's got to pass over that. So that air comes through, and it is being condensed up here. You'll see there's a little bit of a dark spot right around here, it looks like. So there's a condensing coil section to condense the humidity out of the air right around here. And finally, the fourth problem that this solves, which I hadn't mentioned before, is it eliminates the problem of forgetting to take the clothes out of the washer and putting them into the dryer. Sound off in the comments below if that sounds like you. That was a huge problem for us. I work a lot, and my wife, we have kids. So sometimes in the night we'd put laundry in the washer and try to remember to get up and move it to the dryer, but forget. Wake up in the morning to moldy, soggy clothes that we have to wash again. And that happened to us all the time. This solves that, because all we do is before we go to bed, last thing we do, we throw dirty clothes in here, we go to bed, we wake up, washed, dried, ready to rock. Now, heat pumps don't have to be all in one. My very good friend Matt Farrell on his channel, Undecided, made a review of the Miele traditional unit with the washer and dryer. The washer is traditional, and the dryer is a heat pump model. So we'll put a link to that video in the description as well if that's more your speed. We don't really care what model or whatever you pick, again, not sponsored, but this being all in one solved all those problems for us, and that's why it was such a win. Now, that being said, this is not perfect. Actually, you can kind of tell. My wife was telling me about her gripes with this machine, and you can actually see it right now. Because this drum is the washer and the dryer, it has to have waterproof sealing, like a washing machine, right? Not like a dryer. Right now, that sock stuck in that seal is not getting dried. Also, that being a waterproof seal, this whole drum being a little bit moist and now being a dryer as well, lint sometimes a little bit, right? I mean, this captures most of it, but hair and lint can get caught in there. So it requires a little bit of a clean out once in a while. But the biggest drawback by far for most of you, and why this might not make sense, is going to be the capacity. Our previous washer dryer 2-unit system had a 5.8 cubic foot capacity washing machine and a 7.2 cubic foot dryer. This is 4.8 cubic feet. That means that the drying capacity of this dryer is only 2/3 of what I used to have. Now that is possibly a problem. If you have huge loads, like you don't do laundry very frequently, but when you do, you need to do all of it all together, this might be a bit of a problem. Plus, you got to remember, you can't have a washer and dryer side by side where you have one load of laundry in the washer, another in the dryer, and you just keep swapping them, right? You can do 2 loads at once. This is one at a time. This cycle will take about 2 hours when it's all said and done, right? 2.5 hours maybe. And you can't do anything else with it. That could be a problem depending on your use case and your workflow. For us, last thing at night we do, we go to bed, we turn this thing on, and let it run. So that's not a problem. But this could limit you in terms of like a comforter, for example. We have a king size bed, and the comforter does fit in there, but it's obviously a bit of a problem, to be honest with you. But if you have a twin or a queen, it might not be so bad. And you know, the bedding really is the only thing. Otherwise, you can control the size of the load. How about numbers and just general usage? Over the past 30 days, we've done 34 loads of laundry. We have 2 young boys, so they get dirty. Laundry is a constant struggle in this house, as you can imagine. Over the past 90 days, we've done 80 loads of laundry. Just to give you an idea. So when I do my final math on calculations of how much energy it'll use and save you over the course of a year, I'm gonna factor we do 300 loads of laundry a year. We have 53 minutes left, and we're pulling 1,050 watts now. It's moved up a little bit. We are coming up on 1 kilowatt hour of energy. Pretty amazing. I think we'll be maybe right around 2 kilowatt hours actually then. We'll see. Depending on what your laundry looks like, it'll change these numbers quite a bit. Like for example, towels take a lot longer. They absorb water and it takes a lot more tumbling and drying to get that water out. Typical clothes, a lot easier. But here are the numbers. First of all, on average, we noticed that our heat pump system probably takes about 30 minutes longer than traditional, our old gas one, or even electric resistance system. The worst case scenario took an hour longer, and typically about 20 to 30 minutes or so. So keep that in mind. But here are the numbers. First of all, the washing cycle took 300 watt hours or 0.3 kilowatt hours to run. Pretty reasonable. And then the drying took 2 hours at 800 watts on average for a total of 1.6 kilowatt hours. How does that compare? Well, with an electric heater, you'd be running at 4,500 watts for an hour and a half, less time, but way more power, and you would use 6.75 kilowatt hours. On average, we were actually seeing a coefficient of performance of like 4.2, which is really good, meaning for 1 watt, you get 1 watt of heating here, but for 1 watt, you get 4.2 watts of heating with the heat pump. Pretty great. Now, these numbers can change and that can depend upon your load and other factors, but make sure that that drain is working correctly. And again, the filter is cleaned, because if you don't clean the filter on the heat pump and the air flow can't get through properly and circulate, it'll completely bog down your times. Over here on the natural gas side, you would use roughly 0.23 therms per load, and it will take about an hour and a half, sometimes even less, because the gas probably is the fastest. Now, we mentioned, based on our data on the app for the GE heat pump system, we do about 300 loads per year. That's a lot. We have kids. If you have kids, you know how that goes. So if we do the math then, that would be 69 therms over the year, or over 2,000 kilowatt hours for the electric, or 480 kilowatt hours for the heat pump, based on our prices. And we'll put a calculator in the description so you can put your prices per therm of natural gas or kilowatt hour electricity to get these numbers for yourself. But look at this, the electric heater costs $850 to operate for a year. The heat pump, $201. The cheapest is still actually the natural gas, believe it or not, even with our high prices. So that means that we'll never recoup the cost compared to a gas one, but you can recoup the price of this system in about 1 year compared to the electric. Now that matters because the cheapest you can possibly do is an electric washer and dryer, like separate systems, right? That, from what I saw in Home Depot or Best Buy, is about $1,500 here in the US and California. The gas is typically $200 to $300 more expensive for the dryer. So that would be like $1,800. And our heat pump cost us, if we bought it on sale, that's why we did it, because we saw the prices come down. We paid $2,300 for it. So that is a difference of $800 more than electric and about $500 more than the gas. But the bad news is I've been tracking the price for this thing. It is really popular. It's even been sold out and stuff. So the prices are back up, unfortunately. I think they're now over $2,600, $2,700, but definitely check out for sales and things. And that's the differences in prices and stuff. You can put your numbers in, we'll make that easy for you. Now, why wouldn't you want this? If you're the kind of person who doesn't do laundry every day, but on Sunday afternoon, you do 5 loads of laundry, this will be a problem because it takes longer to dry your clothes and you can't be washing and drying at the same time. So if you're a person that does no laundry during the week and then on the weekend, that's your time and you do 5 loads, that will definitely hamper you. Now, some people have told me that they buy 2 of these things, $5,000. That's a lot of money, right? Compared to just doing it this way. The other thing is if you already have a newer system, just keep using it, right? The best thing you can do is just keep using the appliances that you have. You'll never recoup these prices very easily, unless you have an electric one. If you have an electric heater, you should definitely consider this. And if you don't want the all-in-one, again, Matt Farrell has a video on a Mealy system. That's a heat pump dryer, traditional washer. That could make sense for you too. But as we mentioned, this is freaking genius. It really is. If you have one of these inside your house, like in a laundry room indoors, this could possibly even save you money on heating and cooling by not dumping out good clean air to have to vent out all the humidity. So Juan made a really good point too. What if you live in an apartment and you don't have a washer dryer? This would be as easy as putting it in your bathroom, like somewhere near your sink, running a hot and cold line from your sink up to it, take the drain, put it down the sink or in a bathtub, and you could actually run this on an outlet. Just plug it into like any outlet in your room and you can wash and dry your clothes kind of anywhere. That is what makes this so special. So like I mentioned before, if you have an electric dryer, you would need a regular 110 for the washer, one plug. You would need a 240 plug, typically a NEMA 1430 is what I normally see, for the dryer, which is not common. That you'd have to have that already run. Or in the case of natural gas, you would have to have a gas line and your electric, actually two electric, right? You need electric for the washer and dryer, and then you need a big gas line. Running a gas line can cost $1,000 if you don't have one already. Running a NEMA 1430, $1,000. This is literally one plug. One plug you plug in, and you have clothes washing and drying. And that's why I called this the genius of this system. For us, this system is a dream. I would not go back because of this part alone. It was such a pain to remember to get up and swap out laundry. That's gone. You wake up to clean clothes. But it does come at the price of a smaller drum, smaller capacity, longer times. So hopefully that gives you a rundown of why this is brilliant and why it might make sense for you and why it might not. Definitely keep all of this in mind and make the best decisions you can. All right. Thank you so much for watching, guys. This has been fun. I actually have been waiting to make this episode. I wanted data. I wanted to put it through its paces and see how well it held up and stuff. Damn impressed. I got to tell you, GE, good job on this one. All right. Until next week, check out this video. Catch you guys next week.